Hi everyone, it's Coach Fred, and today I'm going to be extending what we did in class with right triangle trig. So let's look at this triangle ABC, and I'd like you to go ahead and put a box there indicating it's a right triangle. So one thing that you need to know when we're dealing with trig is sometimes they label the sides, relating them to the angles that are across from them. So across from angle A, we'd put a small little a. Across from angle B, we'd put a small little b, and then across from angle C, we'd put a small c. Now, we've used those letters before in the Pythagorean theorem, but it's going to be important for us to recognize them using language that we're going to use in trig, the words opposite and adjacent. So if I asked you to name the leg opposite to angle A, okay, then it would be side A, okay? If I asked you to name the leg adjacent to angle A, it wouldn't be the hypotenuse because that's not a leg. That would be side B. That's adjacent, meaning next to. All right, opposite angle B. So opposite angle B would be little b. But adjacent to angle B would be next to it. Again, it's adjacent leg, so that would be A. We're going to be using these terms as we move ahead into our trigonometry unit. All right, so, oops, what happened? All right, so let's get started. So engineers and scientists have found it really convenient to formalize the relationships that we found earlier today by naming the ratios relating them to the sides of a right triangle. So they can be summarized as follows. The sine of an angle, okay, the sine of an angle, that's how we write it sin, but it's really pronounced sine, so S-I-N-E. The sine of an angle is equal to the opposite leg over the hypotenuse. The opposite leg over the hypotenuse, okay? Cosine of an angle, so cosine, but it's shortened to cos, okay? Cosine of angle A would be the adjacent leg over the hypotenuse. And then the tangent of angle A, we shorten it to tan, but it's tangent. The tangent of angle A would be equal to the opposite leg over the adjacent leg. The opposite over the adjacent. And so there's a mnemonic that's been used for years. I even used it in high school to help us, and it's called SOHCAHTOA. Yeah, that's it, SOHCAHTOA. So sine of an angle is equal to the opposite leg over the hypotenuse. Cosine of the angle is the adjacent over the hypotenuse, and tangent of the angle is the opposite over the adjacent. SOHCAHTOA. We're going to be using SOHCAHTOA a lot, okay? All right, so let's look at some examples. So if I asked you to find the sine, the cosine, and the tangent of angle R, I'm looking for the ratio of the angle. So sine of angle R, I'm looking for the ratio, those ratios that we figured out today. So the first thing that I actually have to do is to finish the triangle. It's a right triangle, so I'm going to find the third side by using the Pythagorean theorem. A squared plus b squared equals c squared, or in this case, I'm going to use a Pythagorean triple. So we know it's a 3, 4, 5 triangle. All right, so the sine of R. So first I mark R because R now is my reference point. And sine, so is the opposite leg. So 3 over the adjacent, over the hypotenuse, which is 5. So 3 over 5. So when I ask you for the sine of R, I'm looking for a ratio. All right, the cosine of R. So cosine is the ca. So adjacent leg over hypotenuse. So that would be, adjacent to R would be 4 over 5. All right, the tangent, toa. Tangent would be equal to the opposite leg over the adjacent leg. So 3 over 4. All right, so remember, if I ask you for the sine, the cosine, or the tangent of an angle, then I'm looking for a ratio. Now, it's important to know that ratios can also be written as decimals. And that's when I found it to be confusing when they're written as decimals, so we're going to go over that as well. Okay, but a ratio can be written as a fraction or as a decimal. All right, Let's try, okay? So here I gave you a triangle, ABC, and I labeled one side 7, and I labeled the hypotenuse 25. Okay, so first we want to find the third side. So we would use the Pythagorean theorem. Oh goodness, I did it again. It's a Pythagorean triple. It's a 7, 24, 25. So I'm going to label this 24. But again, you could use the Pythagorean theorem to find that third side. All right, so the sine of A, so I'm going to mark A, the sine of A would be the opposite over the hypotenuse. I'll write SOHCAHTOA up there for us to remember. So it would be 24 over 25. The cosine of A would be the adjacent, so 7 over 25. And the tangent would be the opposite over the adjacent, so 24 over 7. Okay, now I didn't have to ask for angle A. I could have done the same thing with angle B. You're only always going to be looking for the acute angles, never the right angle, okay? Only the acute angles of the right triangle. All right, so sine of B. So sine of B would be opposite, so 7 over 25. Cosine of B would be, there's that 24, would be adjacent over hypotenuse, so 24 over 25. And then tangent would be 7 over 24. Okay, so those ratios have something to do with the angles. So now how do I find the angles? All right, it's time to listen up. This is big. We use NAUI. That's right, we use NAUI. And by NAUI, I don't mean the instructor training course or how you get certified to scuba dive. But that's actually where I got the mnemonic to help me, okay? NAUI means that if we need the angle, we have to use the inverse. Well, we find the angles using these ratios and the inverse function on our calculator. So let's write it just to help us. If we need the angle, we're going to use the inverse. Okay, so let me show you that. Okay, so if I want to find the measure of angle A, I pick any one of the ratios. I'm going to work with sine. So we had sine as 24 over 25. So sine of A was 24 over 25. Okay, so grab your calculators. I'm going to grab that calculator. I'm going to quit out of this. And I'm going to put it right there. All right, so now you might see right here, you've got the sine, the cosine, and the tangent button. Okay, so I'm going to clear that all out, but I want you to see them. The inverse is when you see right above it where it says sine, it looks like raised to the -1 power. That actually means inverse. So we're going to press second sine, and it's going to look like that. It's going to look like sine of the -1. That means the inverse sine. And we're going to type in our ratio, 24 divided by 25, and we're going to get 73.7. Okay, what if you didn't? If you didn't, then that means your calculator's in the wrong mode. So I always check this anyway just to be sure. Press the mode button right here, and you see how in the fourth line it says rating and degree? You want degree highlighted, okay? So let me quit out of that. All right, so let's write it exactly how we put it in. We put in sine -1 24 over 25. Now remember, it doesn't mean -1, it means inverse sine. And it gave us 73, what was it, 0.7? Yeah, 73.7 degrees. All right, so now that we've got angle A, so the measure of angle A, here, let me come out of the way. Measure of angle A was 73.7. I actually don't need to do much more because if this angle is 73.7, these two angles add to 90. So I would do 90 minus 73.7 to get angle B. I mean, you could use trig, but why would we? So 90 minus 73.7 is going to give me 16.3. All right, let's try another one. Here's a triangle. Go ahead and mark it with a right angle. And so we're going to find tangent of A, tangent of B, measure of angle A, measure of angle B. All right, well, let's see. First, we're going to finish the triangle. Darn it, that Coach Fred, she did it again. It is a Pythagorean triple. Do you remember which one? If you don't, it's an 8, 15, 17. Okay, 8, 15, 17. Could use the Pythagorean theorem. Okay, so tangent, so TOA, SOHCAHTOA is the opposite of A, opposite over adjacent. So opposite would be 8, adjacent would be 15, because we're always talking about opposite and adjacent legs. The hypotenuse is never adjacent or opposite. All right, so tangent would then be 8 over 15. Tangent of B, that would be, make B the reference angle, would be 15 over 8. All right, can use either one of those, but we're going to grab the calculator and we're going to put it in and we're going to do the inverse tan. So we're going to press second tan, 8 divided by 15, and that's going to give us 28.1. So angle A is 28.1, and so I'm going to do 90 minus 28.1 to get angle B. And that gives me 61.9. What do you think? Doing okay so far? Okay. Now, how do we use this? So there is a way for us to find the length of a side of a triangle using the angle and trig. So right here we have a right triangle and we have a 24-degree angle and we're missing a side. Now, we can't use the Pythagorean theorem because in order to use the Pythagorean theorem, we need two sides. Okay, so what we're going to do is we're going to write a trig equation. Kind of like we write linear equations and systems of equations and quadratic equations. We're going to write a trig equation. All right, so we're going to use SOHCAHTOA. SOHCAHTOA, and I'm going to mark my reference angle, and I'm going to say what in reference to that angle, what do I have and what do I want? So I want the opposite, and I have the adjacent. All right, so that would lead me to TOA. Okay, so here would be my equation. Tangent of the angle, and the angle is 24 degrees. Tan 24 equals opposite over adjacent. So now I have a trig equation, so I can clear fractions here. So I'm going to multiply both sides by 20 because I'm solving for x. So I've got 20 tan 24 equals x. All right, now this isn't inverse because I'm not finding the angle. I don't need the angle. I'm looking for a side length. So I grab my calculator, okay, and I'm just going to type in now 20 tan 24. And that's going to give me 8.9 approximately. So x is 8.9. Now if I needed to find the hypotenuse, I could, because now I could use the Pythagorean theorem. Okay? All right, let's try one. Here we have a right triangle. We have 56 degrees, and it wants us to find the value of y. Okay, so we write a trig equation to find y. So I look at 56 as my reference angle. In reference to that angle, I want the opposite. I have the adjacent. All right, so tan of the angle, so tan 56 equals opposite over adjacent. And now I'm going to clear fractions, so I'm going to multiply both sides by 32. And that gives me 32 tan 56 equals y. All right, so let's go ahead and put that in our calculator. So 32 tan 56, and we get 47.4. So y equals 47.4. All right, well, hopefully this is starting to come for you, okay? All right, last thing I want you to know is that sometimes you're just going to be asked for ratios given a trig function. So these are trig functions: sine 30, cosine 66, tan 15, and you can just go ahead and put those in your calculators to get your ratios. Now remember, I told you ratios could be decimals, so you got to be really careful. So if I put in sine 30, I'm going to get a decimal, 0.5. Now you could turn that into a fraction if you want. So cosine of 66, let's see. Cosine 66, cos 66 and I get 0.4. Okay, that's my ratio, 0.41. Looks a little funny though, doesn't it? All right, and then tan 15. Tan 15. So 0.3, I'll call that, okay? So 0.3. All right, guys, so that's a nice introduction to trig, how to use SOHCAHTOA, and how to write a trig equation to find missing sides and angles. All right, see you tomorrow.